Today's lesson is 13.2, Independent and Dependent Events. The learning objective is, I can find the probability of independent and dependent events. The essential question is, how can you determine whether two events are independent or dependent? The difference between independent and dependent events is whether the first event does have an effect on the other one or does not. So in exploration 1, letter A, determine whether the events are independent or dependent. Explain your reasoning. Letter A, 2 six-sided dice are rolled. So if you roll one dice, you can get 1 through 6. If you roll a second dice, you can get 1 through 6. This is an independent event because one dice roll does not affect the other one. On letter B, 6 pieces of paper numbered 1 through 6 are in a bag. 2 pieces of paper are selected one at a time without replacement. So let's say you have a bag and you take out 2 pieces of paper. Let's say you take out the 3 and the 6. So your second bag only has 1, 2, 4, and 5 in it. Do you notice how if you pull a number out of the second bag, that will be different than the first one? So when you do not replace something, that does change the conditions. So this becomes a dependent event. This screen encourages you to go ahead and run both of those experiments. If you roll both dice and make a sample space of what you find, that will satisfy letter A. And then if you pull numbers out of a bag, that will satisfy letter B. And then what you can do is compare those probabilities to the theoretical probabilities. Letter A. Find the theoretical probability that the sum of the two numbers rolled is 7. Then compare your answer with the experimental probability you found in 2A. So again, here's where you will compare. So compare theoretical to experimental. What happens when you really run the experiments? There's no right or wrong answer. Every time you run an experiment, you'll have different data. What you should find is that the more you run the experiment, the closer you will come to the theoretical probability. How can you determine whether two events are independent or dependent? That has to do whether one event has an effect on the other or not. Number 5, determine whether the events are independent or dependent. Explain your reasoning. You roll a 4 on a 6-sided die and spin red on a spinner. Well, think about it. If you roll a die and you spin a spinner, they have nothing to do with each other. Those are independent. Letter B, your teacher chooses a student to lead a group, chooses another student to lead a second group, and chooses a third student to lead a third group. Well, that is dependent because once she chooses somebody, well, that takes someone out of the pool to be chosen, right? I don't know, let's say you have a couple people in the choosing here. If you take one out, then you only have one less than that. And if you take another one out, same thing, you're decreasing your pool. So every time one event affects the other, it becomes dependent. These are vocabulary words for your lesson. Independent events are when the occurrence of one event does not affect the occurrence of the other event. Dependent events are when the occurrence of one event does affect the occurrence of the other event. Conditional probability is when the probability that event B occurs given that event A occurs. And that's called conditional probability of B given A. And it's written as P parentheses B divided by A. Probability of independent events. Two events A and B are independent events if and only if The probability that both events occur is the product of the probabilities of the events. Product tells us to multiply, so the probability that both A and B will occur means it will multiply the probability of A times the probability of B. For example, if we flip a coin and we want to know the probability of getting a heads, that'll be a 1 out of 2. If we roll a die and we want to get the number 2, our chance of getting a number 2 will be 1 out of 6. These are independent events. They have nothing to do with each other. So to find the probability of doing both, we would multiply and get 1 out of 12. That's the chance of both of those things happening. Probability of dependent events. If two events A and B are dependent events, then the probability that both events occur is the product of the probability of the first event and the conditional probability of the second event after the first event. In this example from the textbook, this is example 2, lesson 13.2. A group of 4 students includes 1 boy and 3 girls. The teacher randomly selects one of the students to be the speaker and a different student to be the recorder. Use the sample space to determine whether randomly selecting a girl first and randomly selecting a girl second are independent events. So if you select a girl first, your chances are 9 out of 12. And if you already select a girl, then you have less girls to choose from. So the second time it's different, which is 6 out of 9. And then that's, once you multiply that, that's equal to a half. So your chance is 1 out of 2. In this example, number 1, you have 3 white golf balls and 2 yellow golf balls in a bag. You randomly select one golf ball to hit now and another one to place in your pocket. Use a sample space to determine whether randomly selecting a white golf ball first and then a white golf ball second are independent events. These are independent events because it does not say that you don't place the ball back into the bag. So if you have an equal chance of pulling a white golf ball out each time, that is an independent event. Number 2, your friend writes a phone number down on a piece of paper, but the last 3 numbers get smudged after being in your pocket all day long. You decide to randomly choose numbers for each of the 3 digits. Use a sample space to determine whether guessing the first digit correctly and the second digit correctly are independent events. These are dependent events because once you choose one number for one digit, it changes what number you will choose for the other digit. So one event does affect the other. You're trying to guess a 3-letter password that only uses the letters A, E, I, O, U, and Y. So you have 6 total letters. Letters can be used more than once. That's very important. This means it's an independent event. Find the probability that you pick the correct password, Y-O-U. So that's 3 letters out of 6, right? So you would maybe say 1/2, but that's actually not correct. So you have to go through it one at a time. So the first chance you could pick Y would be 1 out of 6. The second chance you could pick O would be 1 out of 6. The third chance you could pick Y would also be 1 out of 6. So if you do 1 divided by 216, let's see what we get. So that's 0.0046293. And as a percent, we move that over to the right, it would be 0.46%. On letter B, you are trying to guess a 3-letter password that only uses the letters A, E, I, O, U, and Y. Letters cannot be used more than once. Find the probability that you pick the password A, I, E. Okay, so A would be 1 out of 6. If you don't replace the letter, then I would be 1 out of 5, and E would be 1 out of 4. So we would get 1 out of 120, which is approximately 0.008333333 repeating. And if we move that decimal over 2 places, we'll get 0.83%. The table shows the number of male and female college students who played collegiate basketball and collegiate soccer in the United States in a recent year. Letter A, find the probability that a randomly selected collegiate soccer player is female. So we're looking for a female player that plays soccer. So it's this number right here, 36,523, over the total number of collegiate soccer players. So we'll have to add this column here, 37,240 plus 36,523, and that is 73,763. So if we divide that, let's see what number we get. So that's about 49.5%. Letter B, find the probability that a randomly selected male student is a collegiate basketball player. So male students will be this number right here, the 31,863. That's what we're looking for. So what are we going to compare that to? The total number of male students. So that would be this row here. So that 31,863 plus 37,240. Let's see what we get for a total there. $69,103. Okay, so let's see what we get when we divide. 31,863 divided by 69,103. That's about 46.1%. Take a minute to reflect and circle how you are feeling about this lesson. Can you find the probability of independent and dependent events? Please reach out for help if you need it. 13.2 is due on Thursday, May 14th.